Hey everyone, so in this video I'm going to go over conditional probability and two-way tables. From the previous lesson we learned that conditional probability is the event B is the probability that the event A will occur, given the knowledge that event A has already occurred. This is written as P, probability of B given A, so this line means given. So basically what's happening is that in this notation, A is the condition on the probability. It must happen first. What this means is that, say you want to compare different groups. Most likely or most commonly we compare like females and males. So usually this is a female or male condition, like a gender condition, because that always happens first in your life. So what's the probability that you like ice cream given you're a male, or you like ice cream given you're a female? So all the conditional probability is that there is a condition put on the probability, which must happen first. Whatever is written second must happen first. So what I wanted to go over was conditional probabilities with two-way tables. We learned in the previous lesson how to use the formula for conditional probability. If you remember, the previous lesson went over this formula: probability of A given B equals the probability of A and B all over B, probability of B. Notice that this is the same as the bottom value, but it actually is much easier to find the conditional probability using a two-way table because all the data is organized for you and you're able to really read the data and see how to evaluate the probability. If you notice, this table is blank, so I'm going to pause the video and I'm going to then fill in the numbers for you. We can talk about how to do these examples. Okay, so I filled out my two-way table. Just a side note, to check if you did your two-way table correctly, add up these numbers here, the 273, 230, and 12. They should give you 515, and then also double check by adding up these numbers, 75, 203, 149, and 88. That should also give you 515. It's a good way to check that your two-way table was done correctly, because this number should always be the same going down and going horizontally. So the first probability they have is, based on the survey using proportions from the table, do you think the school board should recommend building a new high school? Well, the probability I would be concerned with is the probability of people who say yes. This is our notation for writing probability, Y meaning yes. So how many people said yes in this survey? We have 273 out of 515 people saying yes. This is not a conditional probability. It is just a straight up saying, what's the probability of all the people saying yes? So I would get 0.53, which is 53% as a percentage, and I would say yes, they probably should build a new high school because this percentage is over 50%. So yes, because this is greater than 50%. Now, the next example is a conditional probability, and the reason why is because of this. It says an eligible voter is picked at random. Okay, that's kind of similar to what we did in choice 2, example 2, but there's something different about this problem. They say if this person is 55 years old, this is a condition. This must happen first before we can do anything. Do you think they would indicate the town would build a high school? So what I'm doing right now is the probability that they would say yes given they're 55. This must happen first. So what we're going to do is go to our table, and all I'm going to care about is the people who are 55. That would be in this age category, because that's where 55 would lie. So I'm going to zone in on this age category and only look at that row on the table. That's all I care about, is the green row I just highlighted. Now I want to know the people who said yes. So I would look at 66, because those are the people who said yes in that age group. And then out of how many? Well, 149. If you notice, you can kind of see that 273 over 515 kind of matches up the same placement as the yellow circles. That's kind of showing us that we're doing this correct. But because it's a conditional probability, I'm only going to pull from this row because that's the condition. I only care about the people who are 55. So my probability would be 66 out of 149, giving me 0.44, which is 44%. I don't think they would recommend building the new high school because this is less than 50%. So no. So let's look at one more example using conditional probability. This is an example where we're testing whether or not having asthma occurs more often when someone is smoking in a household. So it says, based on the two-way table, estimate the following probabilities, and as a fraction and as a decimal, rounding to 3 decimal places. So it says a randomly selected student has asthma. This here is your condition. Your student that you're picking has asthma. So I'm going to write condition over it. I do this sometimes to help myself. So that is my condition. I'm going to make this A, because it's having asthma. I'll make this A prime, does not have asthma. I'll make this S prime for no one smoking. I'll make this S for smoking. Remember that prime, that little tick means not. So remember this little tick here, this little dash means not. So not asthma, not smoking. That's what I prefer to use when I write these things. Okay, so they want the probability that the student has at least one household member who smokes. So what I'm doing is the probability that someone smokes given they have asthma, because that is my condition. That's what's happening first in this problem. So I'm going to look at my table, and I'm going to say to myself, okay, my condition is having asthma. So all I care about is this row, having asthma. Okay, so what I'm going to do is I'm going to find the probability that someone is smoking given the child has asthma. So that would be 120 out of 193, because that's the probability that I'm looking for. And that would get me 0.622 as a decimal. Now the next one says a randomly selected student does not have asthma. Again, this is my condition, because that's what's going to happen first. So given not asthma, what's the probability that they have one household member who smokes? Smoking. Okay, so this would be, okay, I only care about not having asthma, because that's my condition. So I'm going to look at this row right here. So my total is going to be out of 807, because that's the total I'm using. And what's the probability that they have one household member who smokes? That would be 301. So 301 out of 807. So that would get me 0.373. And then the next question says, do you think whether or not a student has asthma is related to whether or not one household member smokes? And I would say yes, because the probability of smoking given you have asthma is greater than the probability of smoking given you don't have asthma. So this is probably saying that smoking probably has some effect on having asthma. And that's how you guys can calculate conditional probabilities using two-way tables. Just make sure you know what the condition is, because if you notice, I kept on boxing off what the condition was in both the two examples that I did here. Now you could also have conditions going vertically, so be mindful of that. It would be the same thing, it just would be going vertically. So let's do one vertical one just so you guys can see an example. So what if I asked, find the probability of making the condition smoking, having asthma given someone smokes. So that means that I'm only going to look here. How many people have asthma in that row? 120 out of 421 people. And if I divide that, let's see what I get as a decimal. 120 divided by 421, that would get me 0.285. And what if I did the probability of having of not having asthma? Actually, you know what, let's do having asthma. Let's see how these compare, given not smoking. So again, the condition now would be not smoking, so I'm going to look at this box right here, because that's my condition. How many people have asthma in there? 73 out of how many people? 579. So let's see how that, 73 divided by 579, that gets me 0.126. So again, this is another reason to say that smoking definitely impacts someone having asthma, because this one is bigger than this one. So that's again how you guys can do conditional probabilities with two-way tables.